couple of reasons they built it so big. The upper two floors were used for board storage. When you put a 24-foot water wheel on the building, it causes a lot of stress, a lot of pressure. It has to be something that wouldn't fall down. The main reason, though, is they wanted the biggest and the best and the fanciest in the area. It stayed in operations up to about 1890s, late 1890s, and become abandoned. Shortly after 1900, it was sold to the state of Indiana. The property was sold to the state of Indiana by the cement company for $1, with the understanding that it had to be a park, which is a good idea. The cement company kept the water rights. It's a good business idea. It remained empty until about 1928-29, when the federal government come in and restored it, refurbished it. All they had to work with at that time was the four walls. Everything else was pretty well rotted, so they had to rebuild it pretty much from scratch on up. It took them 3 years to do it. When it was finished, it was put into the park system. And the first year Spring Mill Park was open, nearly 15,000 people visited the park. So it was quite a gathering area. The way it operates is the water comes down the flume from the source at the cave, comes down to the water wheel, starts to fill with 60 buckets on the wheel. Each bucket holds 6 or 7 gallons of water. When the buckets get full, of course the wheel turns. When the wheel starts to turn, the big dark colored shaft in here starts to turn. Along with that shaft, there are 4 other shafts of different diameters and different lengths in the system. There are 9 different gears, 2 types. The big flat gear we can all see is a cog gear. One of the little ones we can see in the middle there is a wallower. They're made out of red oak and hard maple. If we put it in gear right now, or in other words, turn the water on, the stone wouldn't turn because that's controlled over here with a separate beam. Right here by this cog gear, there's a beam that runs this way. Hanging underneath the beam, there's another gear. When I push this beam, all it does is interlock the gears. So at that point, the stone will turn when water's on. Little information about the grinding area here. On top we have the corner with the hopper. Underneath we have a horseshoe. It's kind of like a big wood shovel. In the middle of the 2 stones there's a post. Around the top of the post there's little nubs that stick out. When the stone turns, the post turns and the nubs hit the horseshoe and knock it out of the cord. That's what they call their automatic feed system, like this. That's how they got their cord down. A little information about the stones. The 2 big ones against the wall are the original 2 stones from 1817. They were taken off the mill in 1962 after 150 years. They were actually quartz material brought over from France. They came over in chunks. They were used in sailing ships for ballast. They were fitted together and around the outside edge, the iron bands put to hold them together. When they were new in 1817, they were about 5 inches thicker. They wear at a rate of about 1 inch every 30 years. The 2 new stones on here now were put on there in 1962. They're hard granite, they're from North Carolina. About the only difference is they're 1-piece stone. Those were several pieces. Each one of them weighs about 3,000 pounds. When they bought them new in '62 from a company in North Carolina, they paid $600 for them. Nowadays it'd be much more than that. The way it operates is the bottom stone sits here and never turns. Right now the top stone's sitting on the bottom stone. By adjusting this gear on the floor here, I can take the pressure off that top stone and it comes up just a little bit. So what that means is when we turn the water on, start moving everything, the stone will move easier. Because if you left it down and it's stuck for some reason, there might be a whole bunch of broken parts from here to the wheel. Once it gets going to normal revolutions, that's strictly a judgment call. On the big wheel, it's 7. And by the time it gets in here, the stone is doing 96 revolutions a minute. So there's a lot of gears, a lot of systems in there. What we'll do now is we'll just take that stone and raise it up just a little bit. Now we'll turn on the water. Take about 5 seconds for the water to come down and start pumping.
Laura. It's going to start turning.
Look, there's the water on.
Goes over into the waterfall. I can show you. Feel that? Let's start up.
Oh, that's a big building. You want to go in it?
Water, so we don't want to waste water.
Oh,
So we cut it off.
this way.
We have to cut it off ahead of time so it will slow down and stop so that you can engage it during the